Today we are starting a new unit about circles. Chapter 10 is about circles. So our lesson today is just kind of an introduction to different parts of circles, some basic building blocks for the rest of the unit. So we are giving you a list of all the vocabulary words. So taking notes today is going to look a little bit different as I reference a word, a new vocab word, or a theorem or a formula. You're going to flip to that in your chart and take notes, record the definition, a picture, etc. in your vocabulary chart so you can reference it all throughout the unit. So the first big idea is, what is a circle? So this is something we're pretty familiar with, but a circle is the set of all of the points that are equidistant from another point, which is called the center of the circle. So, like if I pick this point to start my circle, then my circle is all of the points. It's the set of all of the points that are equidistant from that circle. We name circles based off of their centers. So let's say this circle has center A. We can either call this circle A, or sometimes you'll see it's like a circle with the center marked circle A. So those are two ways to name this circle. You name the circle based off the point that's its center. So the next thing is the radius. So the radius is the distance from the center of your circle to the edge of your circle. So from the center to any point on the circle. So this is your radius. But this is your radius, and so is this. And this is also your radius. So your radius is the segment that connects the center of your circle to the edge of the circle. The next vocab word is a chord. A chord is a segment whose endpoints lie on the circle. So a chord could look something like this, or it could look something like this, or a specific example would be the diameter. So the diameter is a chord that passes through the center of the circle. So a diameter is a specific type of chord. And if you double your radius, it gives you the length of the diameter. So your diameter is a chord. It's a special type of chord that passes through the center of the circle. And your diameter essentially is dividing your circle into two halves. This is half of the circle, and this is half of the circle, called a semicircle. Next vocab word are concentric circles. Concentric circles are two or more circles that have the same center. So they have different radii, but their center is the same. So we have this small circle, this is its radius. Then we have the larger circle, this is its radius, but they're called concentric circles because they share the same center point. Okay, what is circumference? So circumference is the distance around the edge of the circle. So if you took a piece of string and wrapped it around your circle and then took that string and stretched it out straight and laid it up against a ruler, your circumference would be the length around the circle. So the circumference is the distance around the circle. It's kind of like perimeter for a circle. And so the formula, so go ahead and flip to your formulas now. Now vocab formula. The formula for circumference is either pi times the diameter, or we know that if we double our radius, it will give us our diameter. So you can also use 2 times pi times the radius. That will give you circumference. So circumference is the distance around the edge of the circle. Next vocab word is inscribe. So, polygon is inscribed in a circle when all of its vertices lie on the circle. An example of an inscribed polygon. All of the polygons lie on the circle. So you can have inscribed triangles, inscribed quadrilaterals, inscribed pentagons, hexagons, any type of polygon can be inscribed in a circle as long as all of its vertices lie on that circle. Almost like the reverse of inscribed is circumscribed. So let's say I have a triangle. But basically, a circle is circumscribed about a polygon if all of the vertices of the polygon lie on the circle. So it's kind of like the circle is circumscribed about, which you can kind of think of about as like another word for around. The circle is circumscribed about the polygon, whereas the polygon is inscribed in the circle. They sort of communicate the same idea. The inscribed has to do with the polygon being inscribed in the circle, whereas the circumscribed has to do with the circle being circumscribed about the polygon. So it's like on the outside. Circumscribed is like talking about outside, inscribed is inside. Okay, so in this list of arrows, we're going to hop over to inscribed right triangle. Sorry. So when you have a circle and a right triangle is inscribed in that circle, the hypotenuse of the right triangle is always the diameter. The hypotenuse of a right triangle inscribed in a circle is always the diameter. So what this means is, let's say I told you that this leg of the right triangle is 3 and this leg of the right triangle is 4. We could do Pythagorean theorem, a squared plus b squared equals c squared, 3 squared plus 4 squared equals the hypotenuse squared. Well, this is a Pythagorean triple, so that makes this hypotenuse 5. Well, that's the diameter of our circle. So that means that the radius of the circle is going to be 2.5. So we can use Pythagorean theorem, or maybe it might be a special right triangle, or you could use trig, SOHCAHTOA. So if it's a right triangle inscribed in a circle, that means that the hypotenuse of that right triangle has to be the diameter.